All right, let's go ahead and look at a model. So the model we're going to look at is what affects wages. So we have wages is equal to beta naught plus beta 1 education plus U. That's really helpful for us. All right, so let's go ahead through the interpretation. So beta naught is interpreted as the average wage when all the x's are 0. So when education is 0. So there's beta naught. Beta 1 is the change in wage for a unit change in education, meaning that how do our wages change for each additional year of school we attend? Now, if we actually go to our data and estimate this model, that's where we'll get beta naught and beta 1 hat. Okay, so let's assume that I estimate it and I get beta naught is equal to negative, we'll do this in hourly wages, $3.50, and beta 1 hat is equal to 54.54. So now how do we interpret? Well, now it's just beta naught hat is interpreted as the average wage when education is 0 is negative $3.50. Beta 1 hat is the change in wage for unit change in education is 54 cents per hour. All right, so whenever we have the hat, we just add on the numbers to the normal interpretation of beta naught and beta 1. All right, but now negative 350, do people really make negative $3.50 an hour? Well, again, what we're trying to do here is we're looking at our data where we have education and we have wages. And where does our data fall? Well, it turns out there's very few people that fill out these surveys that have 0 years of education. They might be here, here, here. Everybody else, all the other data is like that. So if I do my best fit line and I have a positive wage, it's really hard to do that best fit line to draw something like this because it doesn't really fit the data well. What fits the data really well is a line that looks like this, and it just so happens then that that intercept, which fits this data the best, is beta naught hat, which is a negative number. Now the people with very little years of education, they actually make money, but we shouldn't, based on the rest of the data, that's what we have. And so this is going to be an example where our t-stat, or rather our r-squared, isn't going to be very high because we're not explaining the data. It might be best to put a best fit line that looks something like that, but that's not what we have right now. Okay, but now let's suppose I want to look at, is 54 cents a lot or a little? Well, a lot depends on how much you were making beforehand. If I was making $3 an hour, 54 cents per hour increase is a pretty sizable increase. But if I was making $50 an hour, 54 cents is a very small increase. And so what I want to do is not put this in terms of numbers, but actually put it in terms of percentages. So each year of education, what's my return on investment? What's the expected return, or what's the percent increase in wages I should see? So to do that, we're going to do what's called a log model. Okay. And so what this means is we change our model slightly by using the natural log. So we have log here, but we're going to use ln, which is the natural log, or log base e. All right, and so what we do now is we say, instead of wages, we take log of wages. So we take the natural log, and that's going to equal beta naught plus beta 1 education plus u. And now our interpretation changes. Our beta naught is the same. Beta naught is still the average. Now it's not the wage, because that's our y variable. Now it's the average log wage when education is 0. So not really a change in our beta naught interpretation. All right, it's just the average y when x is 0, and just understand here that our y is slightly different. Beta 1, though, is going to change. Beta 1 is going to be a percent change in wage for a unit change in education. And so this is the big key, is when we use log, it's not just going to be the change, but it's not going to be the percent change in wage. All right, so that's helpful to tell us is what's going to be our return on investment. For each year of school, what's the expected return that I get? And it'll be a percentage. So to change that, so if we were to look at our average wage, so if I take the natural log of negative 3.5, I can't quite do that, but if I run my model now and do the best fit line, all right, I'll get beta naught hat to be something like 0.25. So that's in log points. That's not a percentage. And if beta 1 then is 0.08, beta 1 hat, this tells me that I'll get a point or an 8% change in wage for a unit change in education. So for each additional year of school I go to, I'll get an 8% change in wage. And you can do that. All right, this is a log model you can do. Now, one thing to note is on the notes on page 18, it sets up the different models we have. So there's a box here on page 18 of the notes that has our model, it has our dependent variable, it has our independent variable, and it has the interpretation of beta 1 hat. And it goes through the 4 different models to have. All right, it'll have level, log, log, and log. So I encourage you, check out this table, and it'll help you with the interpretation. This is the key of how we interpret beta naughts based on that table. Now this has been fun, so hopefully let's finish it off with a log song.